Hello again, Algebra 2. This is the second video for Section 2.6, which is all about special functions. This specific video is about absolute value functions. Now, we just learned about piecewise functions in the last video, and absolute value functions can actually be defined as a piecewise function. We know that when we've solved absolute value equations before, we would take a positive version and a negative version, and that's what this option 2 says. Consider the positive and negative forms of the expression inside the absolute value bars. We'll get to what that means in a second. So, absolute value functions always look like a V every single time. Straight lines, pretend those lines are straight lines, V. Or it could be upside down, but it will never be sideways, because then it's not a function. So if it was ever sideways like that, notice it fails the vertical line test, so that one doesn't work. It has to be either an up V or a down V. It's written as the absolute value of x, but you can have more interesting things associated with it. So like if you take a look at the first example, there's a, there's a multiplier of 3 outside, and then you're subtracting 4 on the outside. So you can spice it up a little bit. This is, again, it's graphed as two rays that are mirror images of each other and meet at a point which we call the vertex. So this guy right here, this is your vertex. And it's mirror images, so left and right are the same, they're just mirror images of each other. Option 1, and that's what this example shows right here to graph this, is to plot points. So option 1, plot points. When in doubt, plot points. So here we go. You pick the x values. You pick all of those. Then you're going to plug in those x values into your absolute value expression and get your y values out of that. Make sure you pick enough x's to get the v or v shape. Sometimes, like for this one for example, if I had only picked positive numbers, I would only see that side of the graph, and I would say that looks like a line, that doesn't look like an absolute value v that I know I'm supposed to have, but because I picked some negative numbers, I see the v forming. So make sure you are getting the v shape. And you see that in the points too. You see that they were negative at first, the y values were negative, but then they got slightly bigger to -1, slightly bigger to +2, and then they start going, or they've gone down now, and then they go back up, so it's like a little trend there. Oh, I see why that doesn't make sense. Sorry, hold on, these aren't in order. So I should have gone -2 to 1, and then 0, 1, 2. They put them out of order. That's strange. Sorry about that. Yeah, so from -2 to -1, it's lower. And then from -1 to 0, it's lower. But then it goes back up to -1 to 2. You see the symmetry there. I don't know why they put them out of order. That's weird. I'm sorry about that. Anyway, so let's graph one of these. That's your option 1 right there. Plotting points is easy. The other option I want to show you is option 2, which is what we're going to do down here for some of these. Option 2 that you have written up here, to graph these, consider the positive and the negative forms of the expression inside the absolute value bars. So if you take a look at these examples down here, they are all similar. Notice that. They all have a 2 and a 1. They all have a 2 and a 1. And I want to show you how they're slightly different, each of them. So for this one, number 1, we are going to take the positive and negative forms of the expression inside absolute value bars. And again, I'm going to recommend pencil for this, because you're going to erase some stuff as you go. So here we go. The positive option is 2x plus 1. The x is just the x that you see inside. But the negative option is 2 times -x plus 1. Notice, it's only the positive and negative forms of the absolute value expression. The 2 hasn't changed. The plus 1 hasn't changed. That's important. I'm going to simplify this guy a little bit. This is actually -2x plus 1, and I'm going to graph both of these. So the first one here, plus 1, I start up here. My slope is 2. Again, I'm banking on you guys knowing this. If you are not sure where I'm getting this line from, please talk to me in class. It's very important that you know how to graph that line, and I'm not stopping to explain it again in this video. Then my second function, my second line, also starts at plus 1. My slope is negative 2 this time. Notice what has formed here. It is an x, which is kind of like the v that we want, but I don't want a v, I don't want an x, I want a v. So the question is, which is it? I said it could be an up v or it could be a down v. So when I have both that form an x together, which one is it? Here's my recommendation for you. You are going to test a point. I'll do this in a marker so you can see it. Test a point. So it's important that you plot carefully. Let's do this. I want to test a point that I see on the line, not the vertex, because the vertex works with the up v and the down v, so don't test that one. Any other point should work though. I see this point right here. So I'm going to test 1, negative 1. And I'm going to test it in my original absolute value expression. So f of x equals, excuse me, to absolute value of x plus 1. I should be able to plug in negative 1 for f of x. That's my y value. 2 times the absolute value of 1 plus 1. Well, I know the absolute value of 1 is 1 plus 1. 2 times 1 is 2. Oh, I get not a true statement. Not good. Because this is false, this point right here is not on my graph. Meaning my graph, and now I can go to marker if I want to, is the upper V. And if you want to, you can erase the V there. I can use marker on the video here. I'd recommend, as you're doing this on your paper, maybe with just a pencil, just erase that lower V. We don't want it because that point we tested is not valid. That point is not valid, but the upper V is. We're good to go. Let's try another one. Let's try the second one here. So now notice everything is in absolute values for this one. So I'm going to take, again, my positive and negative option. The positive option is just regular 2x plus 1. Nothing changes about that. The negative option is negative 2x minus 1. So everything gets negated. Every term gets negated. So I'm going to graph these two. We've already graphed this one over here. So here we go. Up to 1, my slope is 2. Draw a straight line. There we go. You can use like the edge of a notebook or a ruler or a piece of paper to get that line super straight. My other one is down at negative 1 to start. My slope is negative 2. Okay, again, I see the X forming. I don't want an X. I want a V. So this time I'm going to test a point. I'll test an upper point this time. It looks like this point is good. Again, make sure you're graphing these precisely, at least so you know where the points are. It's okay if your line's a little not straight, as long as your points, you know where they are. So, my point is 1, 3. I'm going to go back to the original. Always go back to the original. H of x, almost wrote f of x there, equals the absolute value of 2x plus 1. So h of x is my y value. Absolute value of 2 times 1 plus 1 in absolute value bars. 2 times 1 is 2, plus 1 is 3, and 3 is the absolute value of 3. Hooray! So that works. That's true. Meaning, I like that point. That point is good to go. So I want the upper V. In this case, there we go. Notice how it's moved over a little bit. This one was moved up a little bit. This one moved over a little bit. They can move in all sorts of different ways. There we go. So, notice how this one, again, slightly different. I would take the positive and negative options. We're not going to go through that one right now, but you could if you wanted to. Remember, you'd have 2 times x plus 1. Notice what has happened there. The stuff in absolute value bars is still in parentheses. So I would need to, again, this is the positive version, I would need to distribute that 2x plus 2 to graph it. My negative option is going to be 2 times negative x minus 1. Distribute the 2, negative 2x minus 2. I would graph that and test a point, and I'm good to go. So that's all about the absolute value functions, the absolute value equations that we can graph. There we go. So we will continue working with these in class. Again, the big thing is you need to know the real shape. The shape of the absolute value function is a V. The ones that we saw today were all upward, but I promise you they can go upside down sometimes like this guy. So you know you need a V that's up or a V that's down, never sideways, never sideways. There we go. So I will talk about that some more in class later.